Find all complex zeros of the polynomial function and then give exact values and list multiple zeros as necessary. So here is our polynomial function. We want to find out what are all the complex zeros of this function. So let's list all the possible rational zeros. So recall that to find the possible rational zeros, it's p divided by q. Well, p is the constant, so we have plus or minus 200 divided by the leading coefficient, which is plus or minus 1. So when you divide that, you get ultimately plus or minus 200. Okay, so let's list all the factors of 200. We have plus or minus 1 all the way to plus or minus 200. Okay, so the next thing we want to do is we want to determine what are the zeros. So let's just look at what this would, how would we look at this at the graph. So let's graph this on Desmos. So we have x to the fourth, okay, and then minus 12x cubed, and then plus 53x squared, minus 130x, and then plus 200. Okay, so what's happening here? Well, you can see here that this is a form of a parabola, right? And so what's happening at this parabola is we have where it crosses the x-axis. Okay, so this could be a multiplicity because it's coming down here, hitting the 5, and then going back up. So there is a multiplicity of 2. So 5 is a zero of this polynomial function, and you can see here that 5 is listed as a possible factor. So let's just go ahead and prove that. So we're going to go ahead and write down 5 and then do synthetic division of our function. So we have 1, negative 12, 53, negative 130, and then 200 that are our coefficients of this particular problem. So we bring down the 1, 5 times 1 is 5. Negative 12 plus 5 is negative 7. Okay, 5 times negative 7 is negative 35. And so therefore that's going to give us 18. Okay, 5 times 18 is 90. Okay, and negative 130 plus 90 is negative 40. And 5 times negative 40 is negative 200. So therefore we get a remainder of 0. So that tells us that 5 is a 0. And that means that x minus 5 is a factor. So let's go ahead and write the factored form. We have x minus 5. Now since this is x to the fourth, this becomes x to the third minus 7x squared plus 18x minus 40. So times x cubed minus 7x squared plus 18x minus 40. Okay, so now we know that 5 is another 0 because it's multiplicity of 2, and that is a factor of 40. So let's again use 5 as another 0, and then we're going to use the coefficients for our new factor. So it's 1 minus 7 plus 18 and then minus 40. We're going to bring down the 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. 18 minus 10 is 8. And 5 times 8 is positive 40. So therefore we get a remainder of 0. So 5 is another 0. And as you can see here, that there's a multiplicity of 2 there. And therefore x minus 5 is another factor. So let's write this in factored form. We have x minus 5 times x minus 5. So since this is x cubed, this becomes 1x squared minus 2x plus 8. So we have x minus 5 times x minus 5 times x squared minus 2x plus 8. Now that we have a quadratic, okay, maybe we can factor this. So if we factor this, we have an 8, and then we have negative 2. So what two numbers can we multiply to get positive 8? Then when we add them together, it gives us negative 2. Well, there aren't any numbers, because no matter what, we need to get a positive 8, so we can't factor this. So what that means is we're going to have to use the quadratic formula for that. So now we're going to set this up using the zero product rule. So we have x minus 5 times x minus 5 times x squared minus 2x plus 8. And we're going to set that equal to 0. So we have x minus 5 equals 0, or x minus 5 equals 0, or x squared minus 2x plus 8 equals 0. So x is equal to positive 5, or x is equal to positive 5. So here, now we're going to have to use the quadratic formula. So we know that a is equal to 1, we know that b is equal to negative 2, and we know that c is equal to positive 8. So using the quadratic formula, x is going to equal negative times b, which is negative 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a times c, which is 8. And then we're going to divide that by 2 times a, which is 1. So we get negative times a negative, which is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 8, which is 32, over 2. So that's equal to 2 plus or minus 4 minus 32 is negative 28 divided by 2. So this is 2 plus or minus the square root of negative 4 times the square root of 7 over 2, which is equal to 2 plus or minus the square root of negative 4 is 2i times the square root of 7 over 2. So let's simplify this a little further. We have 2 over 2 plus or minus 2i times the square root of 7 over 2, which equals the following. 2 divided by 2 is 1, plus or minus I times the square root of 7. So that's or x is equal to 1 plus or minus I times the square root of 7. So here are the zeros of the function. We have 5, 5. We have 1 minus I times the square root of 7. 1 plus I times the square root of 7. So let's go ahead and take a look. So let's plug in our answers. We have 5, 5, 1 minus I times the square root of 7, 1 plus I times the square root of 7. Let's check our answer, and there is our result. So that does make sense here, because if we take a look at the graph, okay, you can see here that we have a degree of 4. So that means we should have 2 other solutions. So 2 other solutions tells us that we have an imaginary solutions to that polynomial function.